G'day, in this video we'll be talking about one of the minerals that we actually correct first when we first start working with farmers, and that is magnesium. Magnesium's super important for setting up your plant for success. And we'll go over exactly what I mean by that. Throughout this video we'll be talking about the role of magnesium in the plant, why it's so important, the role of magnesium in the soil, fertiliser options, and then how we can manage for it in a regenerative way. So this video is part of our regenerative nutrition management series. You can either check it out for free on YouTube here as a playlist, or you can also head over to our website where we have the whole course there for free. There's not even email opt-in, which is pretty cool. And there's also supplementary material on our website. So you can go check it out, it's completely for free. So magnesium is super important. And it's an interesting one because on one side, it's super important for plant function. And on the other side, a lot of farmers and consultants manage almost against it due to high cow to mag ratios. And we'll talk about that in a moment. But a lot of people think it's too high in the soil, and yet when it comes to crop nutrition, typically it's not enough in the actual plant. So it's a really interesting one, and I think managing magnesium is one of the easiest things to increase the Brix level in your plant, or the sugar production or photosynthesis in the plant. So what I mean by that is the most important role that magnesium has in the plant is forming the central molecule in chlorophyll. So chlorophyll is this molecule within the chloroplast of the plant, and these are the things responsible for actually capturing that light. And so the very first step in photosynthesis is that these need to capture the incoming light before anything else can actually happen. So super important that we actually have magnesium for these to be made. If we don't have magnesium there, it's simply just an empty molecule, and we don't have the cofactor that actually allows for that light to be captured. So the most important function of magnesium is as a component of chlorophyll. What this allows the plant to do is photosynthesize effectively. So if you see on your SAT tests that you have very low sugar levels, anywhere below 12 Brix, it might suggest that your plant could be deficient in magnesium. There's a whole other things that could be deficient in. So a lot of this conversation revolves around increasing photosynthesis in our plants. And the very first one is super cheap to do is make sure your magnesium is spot on. We'll talk about how to fix that in a moment. But chlorophyll, massive. The next one is the attachment onto ATP. So they're almost like a battery within the plant. So that's magnesium ATP. What this is important for is the functioning of proton pumps. And what that's important for is xylem loading. Now we talked a bit about xylem loading in the potassium video, and effectively what that is the plant moving sugars from where it's produced, so in the leaves, into the phloem to then be transported to sinks. So that could be your roots, your fruits, or even developing leaves. Now, super important you have magnesium there, because in magnesium deficient plants, sugars aren't able to get from where they're produced to where they need to go. So that's roots, fruits, and say young leaves. What this means is that in some cases, there's a 5 times buildup of sugars in your source, and it doesn't get to your fruit or your developing leaves. Super important. So you'll see an interesting graph here where in a magnesium sufficient plant, sugar production or sugar levels are equal throughout the whole plant. In a magnesium deficient plant, you got sugar buildup in the lower leaves because magnesium is deficient first in the lower leaves because it is mobile. So it's high in the lower leaves and then becomes lower as you get into the younger leaves. Super interesting. So next is an enzyme called glutamine synthase. So what this does is combine the carbon backbone to a ammonium compound, brings it together to form glutamate and glutamine. This is super important for converting ammonium into effectively amino acids. So magnesium is required in this enzyme, and without it, you don't get efficient protein synthesis. You get a buildup of ammonium in your plant, and then it doesn't convert into amino acids. Super important. And then following on from that, magnesium is also important for the structure of ribosomes. And now the ribosome takes those amino acids and puts them all together into a polypeptide chain, which then gets converted into a protein. So you'll see here, I've actually laid these out to think about, we capture carbon, that carbon gets converted into sugars through photosynthesis, but we capture it, that gets transported to where it needs to go. For that carbon then to be used in converting ammonium into amino acids, and then into proteins. So magnesium has a very important role from photosynthesis all the way through to protein synthesis. Now, this is one of the most important two things that you can actually get right with your crop production. There's photosynthesis, because we need to drive the actual production of the plant. And the only way you can drive production of the plant is with increased photosynthesis, because that's the engine behind everything. And then next is protein synthesis, because you get all these problems with the buildup of nitrogen, specifically ammonium and nitrate in your plant, which attracts a lot of pests and disease. So with this one mineral, you're hitting on photosynthetic ability of the plant as well as the protein synthesis. Without magnesium, everything goes downhill quite quickly. And interestingly enough, when you don't have enough magnesium, you get a sugar buildup in your lower leaves, which also inhibits photosynthesis. So it seems to be that when you get an increase in sugar production, or it can't get out of that leaf, it prevents photosynthesis. So not only do you get a reduction in photosynthesis because you don't have chlorophyll molecules, you also get a reduction in photosynthesis because you get a buildup of sugars because you also don't have that magnesium to then assist with phloem loading. Now, the problem with this whole thing, when you're magnesium deficient, and it's super important, is that you need magnesium to convert ammonium into your glutamate and then amino acids. When you don't have that, your plant becomes very susceptible to pests specifically. So when you're seeing ammonium high on your sap test, you got to be looking back at your magnesium to make sure magnesium isn't blocking first your photosynthesis and then the actual conversion of those sugars into amino acids. Now, there's also a few roles in lipid production and the production of oils and fats from magnesium, but the real driver of a lot of these things is this effect on photosynthesis as well as protein synthesis. Now, because of these two things, it drives a lot of quality. So in one study, they found that magnesium deficient wheat plants had smaller grain size. So not so much the number of grain or the number of spikelets on the spike, but more so the size of the grain. And so that could be due to two reasons. First one is that limited photosynthesis, which reduces the amount of just sugars or carbohydrates available to be pumped into the grain, or the inability to move those sugars into the grain. Both of those things. Magnesium also important for that quality aspect of increasing the protein content in your plant. If you don't have glutamate and the ribosomes to convert that ammonium into amino acids, then you're not going to get your protein counts up. So in a magnesium deficient plant, magnesium will move from the lower leaves, the older leaves, up into the younger leaves. And so what that means is that the oldest leaves will typically show a deficiency of magnesium first. What that looks like, you see it here, but it's yellowing everywhere other than the veins, and they tend to stay green. You can see that here, I didn't have a yellow marker, so we're using red. So the veins stay green, but the outsides go yellow. What we're looking for in a differential sap test, which is when we sample the old and the newest leaf, if there's a 10% deviation, then we're going into a deficiency. So if we have, say, 200 parts per million up here, and down here we got 150, there's a greater than 10% difference between these two values, and that will suggest that the plant is moving magnesium from the older leaves into the younger leaves, and therefore we should fix it with, say, a foliar application. And we'll talk about how to fix that later in the video. That's what happens. The other thing is that because sugars can't move around the plant, you get stunted root growth, and so magnesium plants will tend to have stunted roots as well. And then finally, you're likely to get a ammonium buildup in the plant because you don't have the magnesium to then produce the carbon backbones to then convert that ammonium. And likewise, you don't have the glutamine synthase to then take the ammonium and convert it into glutamate or glutamate. So the big ones. So you'll likely see on your sap tests a high amount of ammonium in your plant sap when you have a deficiency of magnesium. They tend to go hand in hand. Not always. So if you're using a lot of ammonium fertilizers, you tend to see deficiencies in some other cations, so magnesium, as well as calcium and potassium. And so that's something to look out for. When we look at magnesium in the soil, like all our other macro cations, we have mineral magnesium, we have non-exchangeable magnesium, we have exchangeable magnesium, and then we have soluble magnesium. Now, typically our soils have a lot of magnesium already in them, and typically you'll find that in a lot of Australian soils, we have a high amount of magnesium on our colloids. So if you look at your CEC, they tend to have a higher base saturation of magnesium. So from your mineral magnesium typically comes from your mafic materials. So think more basalts, typically they're going to be high in magnesium. The mineral magnesium will break down and release to exchangeable and non-exchangeable magnesium. So the non-exchangeable is between your clay particles, or your clay plates. You get stuck in there, and your exchangeable will be on the outside of your clay particles, held together or attracted to the negative bits on the clay. Likewise, also with your soil organic matter. So the mineral magnesium will release into non-exchangeable and exchangeable. Your non-exchangeable then exchange into your exchangeable, and there's a equilibrium between them. And then your exchangeable will then go into your soluble. So a plant root can take up your soluble magnesium as well as your exchangeable magnesium. In terms of what we look for in our soil tests, or the soil test we get 3 numbers. We get a total magnesium, which considers pretty much your soluble, exchangeable, non-exchangeable, and some of the mineral magnesium, not all of it, some. We look at exchangeable magnesium, so basically this magnesium, and then we also look at soluble magnesium. And then the other rating on magnesium we also get is the percent of magnesium on the clay colloids. So when we look at soluble magnesium, really we're looking anywhere between 25 parts per million on a sandy soil all the way up to, I think it's 160 parts per million in a heavy clay. So you'll see here, you're unlikely to really get too affected in a high clay soil because there's just so much more magnesium. There's so much more clay and total magnesium for that magnesium to then be recharging your colloids. You're unlikely to get a massive deficiency, at least in your soil, of magnesium on clays. For our exchangeable, we're looking anywhere between 75 parts per million on a sandy soil, all the way up to 290 parts per million on that heavy clay soil. And then finally, with our mineral magnesium, anywhere between 500 parts per million to 5,000 parts per million magnesium. So the totals don't really matter too much past kind of that lower threshold. So if you don't have 500 parts per million, then you're pretty much in trouble. Typically, you're only really going to get magnesium problems from your soil specifically, or the lack of magnesium in light sandy soils. So if you have sandy earth soils, then the lack of magnesium is probably going to drive a deficiency in your plant. Now, a deficiency in your plant in a clay soil is probably caused by other cations antagonizing magnesium. So the big one is ammonium. So that's a massive one, especially if you're applying ammonium fertilizers. So what's interesting about this one is that ammonium comes up here again, and it can have a very damaging effect on the overall plant, because if you have too much ammonium, it's going to suppress magnesium uptake in your plant, which then is going to reduce your photosynthesis as well as your converting that ammonium into amino acids. So what happens is you get a massive buildup of ammonium in your plant. You don't then have the sugars to convert it, and you don't actually have the infrastructure in your plant to convert it. So you get a massive buildup of ammonium in your plant, which then just attracts a ton of pests. So you've got to be quite careful with applying too much ammonium. This actually really comes into play, and I'm currently seeing it with a client that's applying a lot of pig manure. So it's a great source of nitrogen, but a lot of that is ammonium. Likewise, if you're on quite waterlogged soils and you're getting too much ammonium, that might suppress a lot of your magnesium uptake. So that's really worthwhile considering. Likewise, heavy applications of potassium can block magnesium uptake. Calcium, obviously, if you're adding too much lime or gypsum, they'll antagonize magnesium. And if you're on sodic soils, it can all antagonize magnesium. So even on a heavy clay soil where you got all this magnesium, you actually might have deficiencies within the plant simply because you're applying all these other things, or there's so much other cations in your soil that it's preventing the uptake. Likewise, if you're applying too much MAP or DAP and too much ammonium in your plant, that can antagonize the uptake of magnesium too. So it's a really interesting one where typically you have a lot already in your soil, but the interaction effects from other cations can negatively impact the uptake of that magnesium. When it comes to the ideal percent of magnesium on our clay colloids, and some folks say it doesn't actually matter, but it's important to look at potentially everything. What we're looking at for a sandy soil is 20%. So we actually want slightly more magnesium in a sandy soil. It actually drives the soil to be a bit more sticky or stick together. So say 20% in a sandy soil, and that's percent of the affected cation exchange capacity, not just CEC, all the way down to about 12% in a very heavy clay. Now again, it's debatable whether or not that's actually significant and important. And likewise with our cal-mag ratio, we want about a 3-to-1 in our sandy soil and a 6.4-to-1 in our clay soil. Likewise, as we kind of discussed in the regenerative calcium video, the cal-mag ratio does help with flocculation. There's other drivers that contribute to soil aggregation, but this might not actually drive yield, so it does depend. So when we look at the actual storage of magnesium in our soil, typically we're only going to have a problem with our sandy soils, simply because there's just not enough magnesium in our soil. That's why it's important to get a total analysis to know whether or not we actually have total amounts of magnesium that we can draw upon. But typically in a sandy soil where we do have a deficiency in the plant, it's likely due to a lack of magnesium in the actual soil itself, not so much a problem with uptake. Whereas in your clayey soils, you're going to have a problem with uptake due to competition with other cations. So what does that mean? So there's kind of two ways we can fix magnesium deficiencies. If we're in a sandy soil, it's worthwhile applying a bit of dolomite. What dolomite will do is both fix the pH, and that's something we haven't addressed yet, but magnesium is quite sensitive to pH. Once your soil goes below a pH of 6, then magnesium tends to get locked up quite easily, and likewise above 7 it gets locked up. So if you're on very acidic soils, say below 5.5, you really need to consider liming to then get your magnesium up. So dolomite contains both calcium and magnesium with a carbonate, and so you get that neutralizing effect from that carbonate, but you also get a release of magnesium. So you get both magnesium actually added to your soil, but also an uplift in the availability of magnesium because of an increase in pH. So if you're on sandy soils and you don't have enough magnesium, adding a bit of dolomite can go a long way to actually supplying that magnesium to the soil. If you're on a bit more of a clay soil and you already have enough magnesium in your soil, then it's not so much a fix of the soil itself, but it's a problem within the soil environment where you've got too many interactions reducing the uptake of magnesium, which means you need to apply a foliar application. So you bypass the soil and get straight into the plant. This is where foliar applications are great. When you have basically all these interactions within your soil that prevent the uptake of magnesium. So if we did apply magnesium sulfate to the soil, the plant might not even get it because you got all these other things suppressing the uptake of magnesium. So you just got to get it into the actual plant. The best way to do that is with the foliar. So magnesium sulfate, our favorite, highly recommend it. It is the better form of magnesium for foliar applications. And then you also have magnesium nitrate. You get that nitrate as well, so it might be beneficial if you're seeking nitrogen, but I would probably go with the magnesium sulfate because you don't have the nitrate, which has a whole bunch of other problems. So ideally we'd be applying magnesium sulfate, but again, you can apply magnesium nitrate. There is magnesium chloride. Don't get that because you're going to cause a lot of problems with leaf burning. Just stick with magnesium sulfate. It's a lot better source. And obviously you buffer that and the uptake is pretty good. So when it comes to managing magnesium in a regenerative way, typically what we're looking at is, firstly, do we have enough magnesium in our soil? So when we look at our soil tests and we have a sandy soil, typically it's not so much a problem in high clay soils, but sandy soil, we want to make sure we add maybe a little bit of dolomite to increase the amount of magnesium if we're in a sandy soil. So add mag if sandy soil. So that's really the big one. We don't really need to spend that money if we're on clay soils because there's really so much magnesium already in a heavy clay soil. What we want to be doing now is taking differential sap tests to know, are we actually deficient in magnesium? Where is our magnesium going in our plant? Likewise, we want to be looking at our ammonium levels in our plant as well as in our soil to suggest, is the uptake of magnesium going to be suppressed because of magnesium? So if that is, so what we want to do is check sap tests plus our ammonium levels to see if we have a magnesium problem. Finally, we want to foliar apply magnesium in order to just simply provide that plant with magnesium. And so from a regenerative agriculture point of view, I don't think there's too much way around magnesium because it's so important in the plant and it drives one of the most important functions, photosynthesis. And it's also super important for converting that ammonium into amino acids. So the other thing is that magnesium sulfate is pretty cheap. You can buy it as a raw ingredient and make your own foliar applications up. So you don't necessarily need to buy a fancy foliar fertiliser. You can buy this, mix it up with some fulvic acid and apply that out. So it's quite effective. Now finally, there are some biological functions that help with magnesium uptake. The first one is mycorrhizal fungi. So mycorrhizal fungi has been found to help with the uptake of magnesium. Likewise with just other bacteria and fungi, they can increase the solubilization of minerals just in general to release those minerals to the plant. So say for example, with our mineral magnesium, they can assist with taking that mineral magnesium and releasing it into the exchangeable and non-exchangeable magnesium forms. So that's really it. There's not too much involved in terms of biological functions and whatnot from a magnesium point of view, but more so it's super important from a crop protection and crop production point of view, just applying simply chemistry. So magnesium sulfate is typically used in bath salts. Just make sure you're getting magnesium sulfate and not magnesium chloride, because you don't want that chloride component, because it's super important for converting that ammonium into amino acids. I can't stress that enough. If you are applying forms of ammonium, and typically we are through MAP or our starter fertilizer, for example, so MAP and DAP, and if our plants go under any stress, such as heat stress or from the application of herbicides or pesticides and pesticides, the plant can also break down proteins, and a function of that is the release of ammonium. So it's super important that we have magnesium to drive photosynthesis to then be able to convert that ammonium into amino acids. And if you're interested to hear more about that, you can go watch our regenerative nitrogen management video, which talks about all these systems. Now, the very last thing I'll mention is the function of magnesium in disease resistance. Now, in the book, Mineral Nutrition and Plant Diseases, there's not that many references. There are a few references, but there's not too many, and a lot of them actually suggest that magnesium, or the application of magnesium, increase the plant's susceptibility to disease. They say, they make reference in the book that a lot of the times the studies that they're looking at are soil applications of, say, dolomite, not so much the concentration of magnesium in the actual plant tissue. What that makes them suggest is that it could not actually be the magnesium in the plant, but rather the magnesium suppressing manganese in the soil. And manganese is super important for effectively all pest and disease resistance in the plant. So that's another aspect to look out for. If you have high magnesium in your plant, that could be suppressing manganese uptake. Which that's obviously not very good. But overall, the concept of increasing your photosynthetates to then convert that ammonium into amino acids, super important for pest tolerance. So if you're dealing with a lot of pests, magnesium might be the reason why. If this is of interest to you, you can reach out for a free consult with us. We help farmers utilize some practices like this to control pest and disease. If that sounds interesting, sign up for a free consult. Otherwise, my name's Teal. Thanks for watching.